Hello and welcome to another episode on the whitedoggarage YouTube channel. My name is Bob. In this episode I'm going to show you how I made this U-butte brass connector. Nothing special you might think, but it does feature a taper thread, and the method I use to cut the taper thread is probably one that you're never going to see in a textbook. It's one that was shown to me by an old turner many years ago, and it's stuck with me. It's a quick and efficient method of cutting a tapered thread without either moving your tailstock to run it between centres, or having a taper turning attachment, or having a CNC in this modern day. So why did I make this? I made it because I bought an undercarriage cleaning wand. One of these. This is the end. The problem I had was that my pressure washer has this style of connector, which is completely different. I needed to get from my pressure washer to this connection to be able to use the under chassis cleaning wand. So I needed this end to be the same as that, and this end, well, yes, that's where it got interesting. I went back into Tradetools the next time I was around, and I asked them if you could just have a converting connector. No, that didn't exist. And I grabbed a quick disconnect connector, which will connect into the cleaning wand, and it has a female quarter NPT threaded end. All I needed to do was to get back to the workshop and make up a connector. Of course, I started off thinking about how I was going to do that thread. I searched in my stock of tapered thread dies, and the smallest I've got in NPT is a 1/2 inch. So not to worry, I have the trusty lathe, the AL-336, and I set about turning up what is a relatively complex turning exercise if it's your first one, but a simple enough one. The object being that it would fit into this one, allowing me to connect to the under chassis cleaning wand, and would fit into the lance of my pressure washer, enabling me to use it all. The thread we're cutting is a quarter NPT, quarter American pipe taper. Vital statistics: the thread has 18 teeth per inch. It's all imperial. The taper is 1:16. Often said as 3/4 of an inch in 12, 3/4 of an inch in a foot. Critical thing for machining is to know this angle in here, and it is 1.7893 and a couple of other little bits, and normally represented as 1.79 degrees. You can find all that information in sort of available reference material. Here in Australia we have produced the little black book, very thin book, and has handy little references in there, and you'll see down the bottom there National Pipe Taper, and a couple of pages over you can get some critical dimensions. The Americans love this, and that's the Machinery's Handbook. I don't mind it either, which is why I bought one. So here we have much more detailed dimensions that you would need to be machining the thread. You can, of course, always go and have a look on the internet. So we can now head off and start to set our taper and then set about machining our NPT thread. But before I get to turning the taper, I need to do a bit of cylindrical turning. The connector will be machined out of a length of 1 3/8" brass stock, and I start with the end where the taper thread is to be machined. Having chucked it up on the lathe, a mark is placed about 3/4 of an inch or about 19 millimeters in from the end, and that length is then reduced to a diameter of 0.525 inches, 525 thou, or about 13 millimeters. Australian and New Zealand viewers, I'll be using imperial measurements for this part of the video. I'm sorry about that, but I'm doing it for two reasons. The first one being the national pipe taper thread is set in imperial dimensions, and secondly because the Hafco AL-336 lathe that I'm using is an imperial lathe, and it makes no sense to convert to metric measurements. So please bear with me. Cutting the NPT thread, we first need to cut the taper. The taper angle is 1.79 degrees, so we adjust our compound slide angle to a couple of Nats Watsits below 2 degrees, and that should be good enough. It's not good enough. We need to be a lot more accurate than that, and I will now show you how to set up your compound slide correctly to do that taper angle. But before we get into that, I need to refresh your memory on high school trigonometry. I've drawn a right angle triangle, your classic style, so that's your right angle there. That's our angle of interest. I have labelled the various components, so I'm calling the bottom the base, the upright the perpendicular, and this one joining here the hypotenuse. They're classic titles. I don't remember what was taught at my high school in relation to that. As long as you recognise that, that and that as components of the right angle triangle, it doesn't matter what you call them. We're going to call the angle in here theta. Again, you can call it anything you like, Beetlejuice if you like. There are three basic trigonometric relationships. So the first one is sine. We normally cut out the E, and we'll call that angle sine theta, and the relationship there, and we'll call the perpendicular, can you see that? Yeah. P. We'll call the base B, and we'll call the hypotenuse H, and the relationship for the sine of the angle there, the included angle, is the perpendicular over the hypotenuse. The other ones, of course, that I'm sure you remember, are cosine, also called cos, and cos theta, and its relation is the base over the hypotenuse. Final one is tangent, or usually called tan theta, and it is equal to the perpendicular over the base. They're all lengths, right? So it's the length of the perpendicular, length of the base, length of the hypotenuse. We're not worried, it's not a trigonometric class here, so we're just worried about sine, because that's the bit that we're going to use. So the other one we need to remember is the inverse sine, normally written sine to the -1, and what it is the angle whose sine would be the perpendicular over the hypotenuse. So that gives you that angle. They are the two things we need to remember. Now, there's one other relationship we need to mention, a bit of algebra this time. So if we look at this equation here, the other thing we can do is, if we know the hypotenuse, we can change sides. So h times sine theta equals the perpendicular. That will be relevant, trust me. We're back at the lathe now, we're back at the compound slide. We need to set it up accurately for our taper turning. The compound slide on the AL-336 can move about 4 inches, 100 millimeters or so. This essentially forms the hypotenuse of our right-angled triangle, and I'll show you what I mean. I have used a centre punch to place 2 marks on the compound slide and an alignment mark on the slide base. They are 3,000 and 25 thou apart, 3 inches and 25 thou apart. I was aiming for 3 inches. Just how it goes. You punch it and it's not quite there, but you need to know it exactly. So I've made my punch marks, I know it exactly as 3,025. We need to get a dial indicator set up for this. Before I set up the dial gauge, let me show you how the angle is checked. I am using the extended tailstock that is parallel to the direction of travel as my reference. On a bigger machine, you would use a parallel bar running between 2 dead centres. The more travel you have in your compound slide, as you would expect to have on a bigger machine, the easier it is to set the angle. So now visualise a line running along the adjacent edge of the compound slide. Then visualise a second line parallel to the edge of the tailstock that intersects that line. The angle between those two lines is the taper angle. Okay, so I've set my indicator up, zeroed it. I've got it running at about mid-scale, so it's a 10mm dial indicator. The divisions are 0.01 of a millimetre, 0.1 of a millimetre, which is about 0.4 thou. If I unlock this saddle and I run it along, you can see that within reason my extended tailstock is essentially parallel to the direction of travel. Okay, I have set my indicator at 0. I have set my cross slide at 0. I've locked my table. My gib strips are snug. I now move the compound slide through to the second mark. Having reached the second mark, I now bring in the cross slide until I have re-zeroed again. So I've hit the 0 again, and if I look at my dial, the amount that I have brought it in is 90 thou. Returning to trigonometry, the distance the compound slide moves, in this case 3025 thou, is the hypotenuse of our right-angled triangle. The distance the cross slide must then be wound in to return the dial gauge to 0 is the perpendicular of our right-angled triangle. Now, I've got my calculator here. If I key in, and this is where we look at our inverse sine, so second function, sine to the -1, we've got 90 thou, and our cross slide movement is 3025. And when I hit enter, we get, and our angle is 1.7049, 1.705 for argument's sake. So we have to do a little more adjustment. And as an exercise, if we plug in 3025 times the sine of 1.79 degrees, we know that we're aiming for 94.5 thou as the movement. Having loosened the cross-slide mounting bolts, I gave the base a little tap with the spanner to move it a tad, and then went through the angle measurement again. For this job, it ended up taking me about 19 corrections until I got an angle measurement I could accept. So I've finally got there. I've got 94, about 94.3. I get out my trusty calculator. We go sine to the -1, 94.3 divided by 3025, and it's 1.786, 1.79, close enough for this work. So I've cut a test piece here. My taper is 1:16.005, 16.005. Good enough, I think, for what we want to achieve. And at the same time, I've done some threading. The reason I've done that is I'm going to show you a simple technique to do the thread, and that I think is the X factor for this video. But the critical thing is I need to practice, and you'll see why when I actually show you the threading operation. After all that setting up, I can finally machine the taper on the brass connector. My taper length is 0.595 inches, 595 thou, and starting at what will be the small end, I work my way up to that length, making successive passes with the compound slide. Now that the taper has been turned, I am ready to machine the thread. This is the tricky bit, the X factor if you like. On the lathe, the usual techniques for machining a taper thread are to either use a taper turning attachment on the cross slide, or to offset the tailstock and run the bar at an angle between centres. The technique I'm using here requires none of that. Once the taper is set on the compound slide, No further alterations to the lathe's normal running are needed. I have set the lathe up to cut 18 teeth per inch and use the index wheel to determine when I engage the half nuts. As the carriage advances along the taper, I am adjusting the thread depth by less than 1/1000th of an inch for each thread as the lathe progresses. If you do the trigonometric calculations, I won't bore you with that here, the bottom of each successive thread is 1.74 thou lower than the previous one, which is not a big change. My eyes focus on the thread being cut, not the scale on the crossfeed wheel. I'm using a ceramic threading tool, which makes it easier to see how the slight changes in the thread depth are going. Almost there, so I do a check with the QD connector and decide to do a couple of spring cuts to finish it off. A spring cut in this technique is just thread chasing, taking the lightest possible shaving off the taper thread. It's a simple enough technique to use, but it does require good hand-to-eye coordination, which is why I recommend to first practice on a piece of scrap, like I did here. With the NPT thread done, I move on to the other end of the connector. Off camera, I had reduced the spigot end diameter to 1 inch or 25.4mm and cut off the rest of the stock. Mounted in a hex-shaped collet block, I am machining a hexagon surface on the connector so that a spanner can be used to tighten the fitting. The hexagon dimension I am machining is 21mm across the flats. As I rotate the collet block, I am maintaining alignment by referencing the end of the block against the jaw end of the machine vise. Back at the lathe, I'm ready to machine the spigot end to fit the pressure washer lance. To this end I have measured and drawn up its shape, which is shown here. I'm using metric measurements this time. Fortunately, the AL-336 lathes indicator dials have both metric and imperial graduations. Having faced the end of the spigot off, I mark off its overall length using the tip of the lathe tool's ceramic insert. With this as my guide, I machine the spigot down to its major diameter of 17.3 millimeters. The spigot has a lock point recess which accepts an internal clip in the pressure washer lance to hold it in place. Again, I use the tip of the lathe tool's ceramic insert to mark the beginning and end of this recess. The recess is only 5.4 millimeters wide with a depth ranging from 1.15 to 1.8 millimeters. Being so small, I machine the recess using a parting off tool. With the recess completed, the parting off tool is used to machine the 3 millimeters on the end of the spigot down to a diameter of 14 millimeters. The compound slide is then rotated to an angle of 28 degrees and is used to machine a bevel on that end. finish the connector, a 9.8mm diameter hole is drilled through the centre. I did say I'm using metric measurements for the spigot end, but those of you who are bilingual in metric and imperial measurements will immediately recognise that dimension is close to 3/8 of an inch. The hole diameter was the last measurement I took on the plastic spigot, and at that moment realised I could have used imperial measurements. Never mind. Before I remove the connector from the lathe chuck, I test fit the pressure washer's lengths, and I'm happy with the fit. Having wrapped the NPT thread and Teflon tape, I then screw the connector into the quick disconnect fitting. And that's the connector ready to be fitted up and connected to the lens. So I hope you enjoyed the video, and if you did, I'd welcome a thumbs up, and by all means share it amongst your friends. This channel is about making, maintaining, fixing and restoration projects, and if you like that sort of stuff, you've not already subscribed, well, please hit the subscribe bar down below, and while you're there, don't forget to ding the bell. Thanks for watching. I hope you will join me for the next episode on the White Dog Garage YouTube channel. Bye!